Today's lesson is 1-1 Variables and Expressions. The learning target is to write algebraic expressions. Now let's talk about some vocabulary. Quantity is anything that can be measured or counted. A variable is a symbol, usually a letter, that represents quantities that are unknown or that vary. Algebraic expression is a mathematical phrase that includes one or more variables. Numerical expression is a mathematical phrase involving numbers and operation symbols, but no variables. Now we're going to talk about terms for operations. When reading any type of math problem, you have to understand what words tell you to perform which operation. So here is a short list of possible terms that you could come across. For addition, you could see sum, total, altogether, more, or more than. For subtraction, difference, minus, less, and less than. For multiplication, product, times, twice, and of. Division, quotient, divided by, per, or separate. Now, these first ones, sum, difference, product, and quotient, are special words because they tell you that that is the answer to an addition problem, or subtraction problem, or multiplication problem, or division problem. So that means you perform the operation and use the answer. That will make more sense when we get to writing expressions with two operations especially. Okay, so these are the terms that you need to be familiar with and know which operation the problem is asking for with each one of these. And again, sum, difference, product, and quotient are all the answers to an arithmetic problem. Now we're going to write expressions using addition and subtraction. Number 1 says 25 less a number n. So the first thing we're going to do is underline the operation, which in this case is less. If we look at our chart, we know that less means subtract. For the majority of problems, you're going to write it in the order that you read it. 25 less n. So our answer is 25 minus n. Number 2 says 32 more than a number n. Identifying our operation, we underline more than. Now in the last problem I told you that most of the time you're going to write it in the order that you read it. This word then, when you see more than or less than, that's when you don't write it in the order that you read it. So I consider it the magic word then. It changes things. And when you see the word then, you're going to change the order. So whatever comes first is going to be written after the operation, and whatever comes after the operation is going to be written before the operation. Since it's more than, our operation is addition. So we're going to write it. 32 is going to come after the addition because of the magic word then. So we actually end up with n plus 32. You might be saying it doesn't matter with addition whether you write it n plus 32 or 32 plus n. And that's correct, except it wouldn't be following the way it was written in words. And it's really important to learn that magic word then for subtraction because as you hopefully already know, it would change it for subtraction. Now we are going to write expressions with multiplication and division. Number 3, twice a number n. Underlining the word twice because that's our operation. So if we look up top, that means multiplication, but the word twice gives us extra information because it's not just multiplication, it's also 2 times something. Okay, so we're talking about multiplying something by 2. Now there's no magic word then, so we can just write it in the order. You're only going to see the magic word then when you're talking about addition and subtraction. So we have twice a number n, and in algebra we try and get out of using the multiplication symbol, so we just have 2n. Number 4, a number n divided by 6. Divided by is going to be the operation, which is division. Now, as I stated above with multiplication, we try and get out of the habit of using the multiplication symbol. Instead of using the division symbol, we most often use a fraction bar. Now, if you're using the division symbol, you would just write it in the order that you read it. Using the fraction bar, the first piece of information, whether it's a number or a variable, is going to be the numerator. So here we have a number n divided by 6. Now we're going to write expressions with two operations. Number 5. 9 less than the quotient of 6 and a number x. The first operation that we see is less than. We know that that's subtraction. We also see our magic word then. And when we see the magic word then, we know that everything before the words less than is going to come after the subtraction, and everything after the words less than is going to come before the subtraction. So we know I can start over here that my problem's going to end with minus 9, because that has to come after the subtraction. The other operation that we see here is quotient. Now, quotient was one of our special terms up top. It is the answer to a division problem. So the quotient of 6 and a number x. So we are going to do 6 divided by x. Now, since it's the quotient of 6 and x, that means you have to divide first before you subtract 9. Due to the order of operations, parentheses are not necessary. However, when you're talking about one of these starred terms, you have to ask yourself if you need parentheses, because you need those answers before you can perform other operations. Number 6, the product of 4 and the sum of 12 and a number x. So the first operation we see is product, which is another one of our starred terms. So we know that we're looking for the answer to a multiplication problem. And the sum, which is also another one of our starred terms, of 12 and a number x. So we have two starred terms in this one. This one's going to require parentheses. So we're looking for the product of 4 and the sum. So that tells me I have to find the sum first before I can find the sum times 4. So whenever I'm going to have to perform an operation first, I use parentheses. So I have 12 and a number x, because sum means addition. We have to perform that first, so we put it in parentheses, and the product means we multiply the answer to that by 4. So you can see why these starred terms are really important to understand, because if we're looking for the product of 4 and the sum, we need to find the sum first, so we put it in parentheses. Using words for an expression. Now we're going to take the expression and write words for it. So the first thing that we're going to do is identify the operations. 10x plus 9. So 10x is multiplication. And we have addition because you see the plus 9. So we have two operations here. Now there is more than one way to write this, and everybody may do it differently. I wrote 9 more than the product of 10 and a number x. You may find an easier way to write this. However, I'm trying to incorporate all of the skills and ideas that we just discussed. Number 8, we look at the operations. We have n divided by 3, so we have division. And we have plus 2, so we have division and addition. I wrote the quotient of a number n and 3 plus 2. Just like in number 7, there were other ways to write this. There is not just one answer. Now we're going to be writing a rule to describe a pattern, which is another way of saying writing an expression. Number 9 states, a state park charges an entrance fee of $20 plus $18 for each night of camping. Complete the table. Write a rule in words as an algebraic expression to model the relationship of the table. So we want to first think about how much it would cost to go to this state park. Everybody's going to pay an entrance fee of $20, plus they will pay $18 for each night of camping. So if you were going to stay there one night, you would pay $18 times the one night plus the $20 flat rate that you have to pay just for staying there. If you were going to stay 2 nights, you'd pay $18 times 2 for 2 nights plus the $20 flat rate for staying there. And if you were going to stay there for 3 nights, you would have 18 times 3 plus 20. Now we want to know for n nights. Well, if we look at the pattern that we just established, the piece of information that is changing, the variable, is going to be the number of nights that you stay. So in order to write this as an algebraic expression, we can just replace the number of nights with a variable. So our algebraic expression would be 18n plus 20. And it was easy to establish that when you make a table and plug in the values and see how the pattern's going. And that's why it's called writing a rule to describe a pattern. So now we're going to write this in words. In words, I would say 20 more than the product of 18 and the number of nights n. Now here are 5 sample problems for you to practice because it's your turn. Tomorrow when you come to class, you should have all of the notes filled in, plus these 5 problems completed, and we will go over them and answer any questions that you have. Have a great night.